Thank you very much, and good morning, everybody. The other speakers have kind of been talking about a shift left, and I'm going to basically try and emphasize that and make some suggestions about various things that you can do in your DevOps pipeline to help improve security. But I think overall, DevOps is really an opportunity to make security better and do it in a much more interactive and much quicker way than has traditionally been done. So I'll talk a little bit about the new attack surface that most organizations are exposing themselves to as they make the transition to DevOps. Effectively, things are changing quite a bit, and a lot of the vulnerability assessment techniques that have historically been used are not really capable of addressing the attack surface as DevOps is implemented very nice. A couple slides on changing technologies. We'll talk about waterfall to infinity. I just use the word infinity because typically DevOps and agile development cycles are represented that way. We'll talk about the increased security risk, possibly that are implemented by DevOps. Then we'll talk about some techniques you can use by applying specific tools to various stages of the DevOps pipeline. And these specific tools, I'm a vendor, but I'm actually suggesting other people's tools as well, just besides Tenable's tools. I wouldn't do that, right? It's an ecosystem, guys, right? It's not just one vendor solution anymore. So we all respect that. So we'll talk about that. And then I'll do a slightly deeper dive into containers, because to me, DevOps and containers are intimately related. So when I was a developer, I'm back in the tin can days when everything just ran on iron. And things have changed so much over the past 15 to 20 years, from the advent of virtualization to web applications. Everything's a web app now. The emergence of the cloud with the dynamic computing environments the cloud brings in. But most significantly, in terms of our conversation, the linkage and technology of containerization, which in my opinion has really taken the world by storm over the past 3 to 5 years, really. But containerization and the DevOps methodology are intimately related, and evidence of that is basically the 6 vendors out there, Tenable included, that are basically trying to give you various forms of softwares that would help you to understand and analyze your containers from a vulnerability and risk perspective. So technology has emerged over time. I just want to remind everyone what the technical word or what the definition of DevOps is. And really, DevOps is nothing but a methodology, a way intended to reduce the time from something being committed to a design change to having that become available. And the integration of development and operations has really made this absolutely 100% possible. But again, emphasizing the point that DevOps tool chains, I'm not saying containers are DevOps, but heavily leans towards a containerized type of implementation. And as a matter of fact, Tenable is essentially preaching this, but we're also eating our own dog food, because our latest technology, which is Tenable.io, is fully and completely implemented using containerization. So if I look at the attack surface, just to illustrate the point of where containerization has an impact on the threat surface, historically, if you look down the bottom, when you perform vulnerability assessments, I'd say most organizations are still at this point, where they're probably doing vulnerability analysis and security analysis in detail at more or less what amounts to a somewhat physical layer, or physical level, server level, desktop level, network infrastructure, and of course, to some degree, looking at web apps and virtual machines and mobile laptops where it kind of overlaps. But the interesting point is most organizations at this point, that's not working right, most organizations at this point are not really doing a very good job evaluating the vulnerabilities and risk that are imposed by the containers themselves as those containers are actually deployed. And that's because the way you need to perform the vulnerability assessment on something like a container and a security analysis on something like a container, which has the characteristics of being fairly lightweight and not living very long, traditional methodologies don't actually work. So this is effectively expanding the attack surface by which a bad guy can actually get into your infrastructure. So effectively, one of the messages I hope to convey is that the ways you need to do this, the methodologies you need to assess your cyber exposure risk need to change to adapt to the changing technology landscape that we all find ourselves in at this point in time. It adds a lot to the cyber exposure gap. At this point in time, of organizations, and these are very recent numbers, organizations that are leveraging containers, only about 18% of these organizations actually do any kind of container scanning to assess the containers for vulnerabilities and risk. And that can be pre-deployment or post-deployment type of scanning. Organizations' abilities to assess cybersecurity risk are fairly low, 52% and 57%. I think probably the most interesting statistic on this slide, though, is the average number of vulnerabilities in an official Docker Hub image is about 15 or 16 for an official Docker Hub image, and community images are much, much, much worse since nobody really cares that much, 40 vulnerabilities per image of things that you might pull off a Docker Hub. And as we were discussing earlier with the previous speakers, developers will grab whatever they can to make their jobs easy. So there might be an awful lot of these community images in your environment that you don't necessarily know about. Containerization is also exploding over the past several years. 40% over last year, 8 billion different container downloads, 500,000 Dockerized applications that people are leveraging in Docker Hub at this point. And again, 15.9 vulnerabilities, 40.5 vulnerabilities, and only 18% of organizations are actually looking at what's inside these containers to assess the risk that these containers may impose. Okay? So we've got that issue. Lots and lots of these things everywhere, and it's not stopping anytime soon, which is actually good. Modern applications basically raise the stakes with additional risk. The point of this slide is really this fact here. On average, about 70% of the code in most modern applications is something that you're leveraging from someplace else. And again, it may end up being kind of a black box. Everybody loves open source, including myself, but who's maintaining the open source, and how much risk is this open source that you're pulling into your build process exposing you to, whether it's a library, whether it's source code by itself, or whether it's already a containerized application, right? Unless you look at this stuff as you're integrating it into your software, you're not really going to have much of an assessment or much of an idea of the risk that these various components are bringing you into. And the final key point is, what's the KPI of a developer, right? I think the KPI of a developer is get your stuff done as fast as possible, make it work, move on to the next thing. But is security one of the KPIs of most developers? If you begin to integrate security testing into the DevOps pipeline, it implicitly makes security, since it's one of the tests, one of the quality points, one of the touch points, one of the gateways, it implicitly makes security one of the KPIs of your developers, because they have to pass that test in order to move on to the next phase, in order to push the thing into production, for example. If you don't end up shifting left, if you don't end up putting security testing deeper into the DevOps pipeline to the left, then what's going to end up happening is you're not really going to have much of an impact on the quality of security, and DevOps Sec is going to continue to be a fantasy. So you need to make it a KPI of the developers that the security testing is fully integrated and tightly part of the DevOps pipeline. So generally, most organizations are taking notice of this. And again, this is a quote from James Ford, who is the Chief Strategic Architect for ADP. He's not going to trust anybody. He kind of wants to do a little bit more of the verification himself in order to ensure that his applications are secure. You've seen this picture a dozen times so far today. I'm not going to amplify it, but this is, I think, in a lot of cases, the state of affairs. The poor guy of security is up to his knees in the rainbow of the DevOps lifecycle. So this is kind of not the coolest situation to be in. And this picture is not funny anymore because you've seen it too many times today. So we have the traditional separation of development and ops, the traditional stovepipe environment that we've all came to know and love. I will say, if you look at the traditional stovepipe development methodology, I think if you think about the opportunity where DevOps breaks everything up and puts everything into very small, containerized, very small parts that are easily digestible, I think it's a lot easier to get security into the DevOps pipeline early than it is to get security into a traditional stovepiped environment, because of the fact that everything is agile and the process is continuous and you're always making a perpetual state of change. And the process is supported by a set of tools that make it somewhat possible for you to inject security into the DevOps process overall. Okay, so speeding things up, we've become a lot more agile than we were with the stovepipe development methodology that we've been using until maybe the past 7 to 8 years. So things are at least getting a little better there. But again, if you remember the original quote, the purpose of DevOps is to allow changes to be implemented really fast. That is brought about by the integration of development and operation into the whole process overall. And of course, we all know the way that software is built is a lot different too. And this is an opportunity and a problem. I think it's more of an opportunity than a problem at the same time, because the transition to microservices architectures to me means that if a component of your application does have some kind of security issue, it's a lot easier to get that security issue resolved because of the fact that you're only replacing a very small part of the subsystem, and you don't need to replace or rebuild the entire application. So it's a lot easier to implement a change, either a security change or a functional change, as a result of the transition to microservices architecture. So again, the leveraging containers, the ability to change part of the application very quickly and simply without having to redo the whole application, I think is a huge benefit. However, there are some issues if you look at how you would perform vulnerability assessment on an application that's built with containers, because containers are lightweight things. They don't have unnecessary baggage in them. It means that traditional security assessments using automated tools, traditional vulnerability assessments fundamentally won't work with a container for several reasons. One of the reasons is the containers aren't really smart enough to allow you to even begin to use a tool. For example, if I try to scan a container with something like Nessus, it ain't going to work, because Nessus requires SSH or SSL. You have to log into the thing, and the container itself doesn't have the ability to let you even do that. So you can't perform a vulnerability assessment of a container using a traditional methodology. One thing is true. The second thing is containers typically have a very short lifespan. Everybody in this room knows the analogy probably of a cattle versus a pet. A container is a cattle. It does its job. Then you shoot it and instantiate a new container. Whereas a traditional application is more like a pet. A traditional monolithic application is more like a pet. You keep it around a lot longer. The point is the short lifespan of a container means that they're not going to be living long enough for you to be able to perform a vulnerability scan on that container, because the chances are the lifetime of the container is shorter than the window between scans. So the amount of time that can elapse between a scanning container and the amount of time that elapses between scans and the life of a container are completely different. Again, second point, you can't use traditional vulnerability management technologies. I've already talked about that. And the third point is generally containers are built in such a way that you can't even patch them anyway. You got to go back to dev, rebuild it, push it back out into the repository, and then reinstantiate it. So traditional vulnerability assessment technologies, traditional security analysis technologies fundamentally don't work with containers, which means you need to change the way you do this when containers are a part of the picture. So I'm going to go and I'm going to effectively show you, I took the infinity sign and I kind of flattened it out into the various steps that are part of the DevOps process: plan, code, test, release, deploy, operate, and maintain over time. These are the same things that were in my infinity sign that, again, everyone in this room has probably seen 500,000 times. So we flatten out the process. We then put in the various tools that support the various steps of the process, from source control to build to the image registry part where the images of containers might live, to the containerization host, and to the orchestration component that basically will fire off the containers as and when required. And on top of that, the whole point of this is that the earlier in the development cycle that I can implement any kind of testing, the better off everybody's going to be. So when we all talk about the shift left, And there are many opportunities and many different types of tools that can be used to help shift the security problem to the left, resulting in a higher quality and more secure product at the point of deployment, and also resulting in the ability to detect things early. And one of the great things about detecting things early is it actually has a very, very significant cost benefit. Costs are reduced by at least 85% when vulnerabilities are detected before deployment. And part of that is probably the fact that vulnerabilities that are exploited are extremely costly. It helps to reduce false positives. And I think one of the biggest things is that there's a big improvement or perceived improvement in overall software quality if you catch these things earlier in the development cycle as opposed to later in the development cycle. So catching things early actually has a lot of besides security, it also has a financial benefit. So now we're going to overlay, we've got the DevOps pipeline. We've got the various components that are used to support the DevOps pipeline. And now what we can do is overlay some testing that you can perform at each step of the DevOps pipeline in order to help you to detect these security issues fairly early. And I said I'm not going to talk about any specific vendors. I'm not going to just pretend Tenable is the only company on the planet that can do this. But effectively, security is an ecosystem, and you need to get the best tool possible to support what your security problem is. And I hope that that message is also conveyed here. So if I look at pre-commit and commit time testing, what can I do early in the development cycle as early as possible? Well, one of the things I can do is maybe do some source code analysis to catch those one-off problems, to catch any poor coding practices that might be taking place as the developers begin to write their code independent of the specific language. So doing that and making sure that some kind of source code inspection tool is included as part of your DevOps methodology, I think is a very important thing to begin to implement. So again, shifting left, getting to the very basic things of doing some sort of source code inspection. I think this other thing is coming up quite a bit, and that's dependency checking. So I made a point earlier about the heavy use of open source software projects, and I think some of the other people here have, and no one is having a go at open source. We all know it and we all love it. But who's maintaining that open source, and how deep is the dependency tree? And what other components are being brought in that may include vulnerabilities as part of your leveraging open source? Part of that 70% you get from somewhere else, how vulnerable is that? When performing a pre-build, pre-link, or pre-container generation check on the dependencies and the vulnerabilities that those dependencies might bring into the picture, I think is something else that helps you to get a higher quality and more secure software piece at the time of pre-build, pre-commit. So performing this early is very important, and these two things will catch an awful lot of problems before the container is actually deployed. We look at build time testing, and these are some other things that you might want to do at the point at which the build and the point at which the initial image is actually generated. One of the things down here, I think that a lot of people may not do is some kind of an API vulnerability check. So looking at the API for security risk and vulnerabilities, the specific tool we're looking at there is something called Postman, the guy leaning over like that, which is one of the more viable tools. Performing some kind of a web application assessment early before the image is put into production is something else that needs to be performed. I think that's going to also be something that's done continuously. Then at this point, you're kind of building the container. So I think looking at the container as an entity by itself, independent of the other checks that you've done, because you're pulling in stuff from all over the place when you finally build the container out. Looking at the container and assessing that container for vulnerabilities and the presence of malware, I think is something else that could be done in a great shift left at build time and at test time in order to assure that the container itself isn't vulnerable before you push it into production. So now if we look at release time and deploy time, a couple more checks that I think ought to be put in. I think that the web application assessment needs to continue to take place. Container vulnerability assessment is something else that needs to continue to take place. The thing we're adding here are security checks on the overall platform. So obviously the container is going to have to live on something. We're talking about performing some kind of security analysis or vulnerability assessment on the platform that is supporting the execution environment for the containers at this point. So these are release and deploy time tests. And the final step in the whole picture is what I like to talk about is continuous operational tests. So fine, everything's great the day that the developer pushes the container into the execution environment, into production. But what happens after that container is a week old or a month old if it doesn't change? Have vulnerabilities been disclosed that would impact the security of that specific container? So the message here is that once you push these things into production, you need to continuously assess them for vulnerabilities that may have emerged since the time at which the initial container image was generated. So continuous assessment of the platform itself, of the web application itself, if it's a web-based application, and of the container image itself, doing it all the time, looking for new vulnerabilities or things that may have cropped in since the thing was initially published, is something else that I think is fundamentally important. Understanding the impact that various layers might have on a container is also important. And this is, I think, important in terms of reducing false positives, because everyone who knows how containers are built knows there's a layer, 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 layer. It's possible for an upper layer to supersede a lower layer and render vulnerabilities that are in that lower layer irrelevant, because the upper layer basically blocks access to the lower layer. So the container assessment technology that you use probably ought to be able to have some fundamental understanding of the various layers that are part of the container. And again, I mentioned this already: continuous monitoring of non-production or production containers. Automatically retest as new vulnerabilities are disclosed, because there's going to be new signatures, new vulnerability assessment things pushed down into containers to understand that. We will have that and performing it again continuously along with the other things I talked about is something I think that's pretty significant. So I'm just going to kind of graphically tie everything I've been saying together in probably a more simple diagram that I think will make a lot of sense to everybody. So if I lay out the process of what I'm talking about in terms of assessing containerized or container images, on the left side, I've got the build tools. I have the ability to take container images from public registries which have unknown vulnerabilities. Remember that average of 40 vulnerabilities per container that we had. Together, put both into the registry, perform the build. The orchestration platform, for example, Kubernetes, will fundamentally deploy as required onto the platform. The thing here, I think that's another important attribute that might be desirable if you're doing some continuous monitoring of the containers, would be to have some kind of a policy that would, if a container is in the registry waiting to be deployed, and if that container has a vulnerability or is exposing you to some kind of risk that is untenable, no pun intended, a policy, automatic policy, should be available to block that container that puts you at risk from actually being deployed at the time the orchestration wants to instantiate that. So that would need to be coupled with some kind of an alert to the development team or to the security team that something's wrong and needs to be fixed. So implementing a policy at the intersection between the registry and container host, I think, is something that's pretty significant. We talk about the shift, stay right and shift left is the point of this slide. And again, I alluded to this earlier when I had my flattened out DevOps pipeline. Before the developer pushes the completed container into production, I think that this is a good final test for the developer to perform. Looking at the complete container as built before it's pushed into the registry for execution. So doing that at the time just before is a good final sanity check to make sure the container does not expose you to any type of security risk. I think that's one thing. And again, to my previous point, in production, automatically and continuously assess the risk of all the containers that are in your environment to ensure that those containers haven't had additional vulnerabilities, the additional vulnerabilities have not been disclosed since the container was built that would impact your production environment to some kind of a major security risk. So again, stay right and keep left at the same time with this technology. So at a high level, I talked at the very beginning of how the way you assess applications needs to change in light of the use of containerization. And with a monolithic application, I'd probably be doing some kind of an assessment against the platform itself, looking for, effectively operating system or application layer vulnerabilities that we might have in a traditional monolithic environment. And I might perform a good external web application scanning against the overall application. But that, with a modern application built with microservices and containerization, that doesn't do the job anymore. Again, because of the fact that you cannot perform a vulnerability assessment against a container image, because the container image isn't smart enough to even let you do that. So the additional step, in addition to all the other things I talked about in order that you probably want to integrate into your DevOps pipeline, the additional step is that you need to perform an assessment on the containers themselves to ensure the containers themselves aren't exposing you to risk. So when I change from a monolithic application to a modern microservices type of application, I have to add this additional step to address the cybersecurity exposure gap that I talked about on my opening slides. So you have to absolutely positively change how you perform your vulnerability assessment. And again, to my point, it needs to be done on a continuous basis, not something you do every day, because the risk profile of each application will change continuously. One final thing, and then I'll take any questions you might have. There is a CIS benchmark that you can apply to Dockers. If you're not aware of it, this is a good way to assess your modern application for vulnerabilities. So CIS Docker benchmark is a good test that you can apply as a sanity check to ensure that your container images that are built with Docker are indeed secure. So we highly recommend you at least look at using the CIS benchmark as part of to measure the security of your deployed containerized types of applications. So with that, I knew I wouldn't need an hour, okay? And I think going for an hour would make everybody kind of fall asleep. But at this point, does anybody have any questions for me? Or the early speaker's going to get up pretty quick. Any questions from the audience? Going once? Going twice? Okay. All right, that said, please do visit our booth out there, and we'll give you a demo of what we have. And there are plenty of other companies out there that will also provide facilities for you to be able to do the shift left that you all need to do. Thank you for your attention.